in our mind was to bring every step of our methodology deeper, and in this line now we have the concretization of strongly the decomposition of the ODD and the scenario, how this works based on the Pegasus approach together. And this is Helmut Schittenhelm. Ach, da ist er ja. I looked for you when he stands on the right, on the right side. Helmut represents Mercedes-Benz and is manager for safety performance driver assistance system. And he was one of the strong core leaders. We called it Core 5, also integration unit in our project, which concerns about the overall methodology. So means that all you have heard now has to put together. And that's, of course, one of the strongest tasks. It's in his responsibility. And yes, the stage is yours.
So, thank you, Roland. So, maybe concretization means coming a little bit down to earth and looking at the details, how to implement it. So what you see here is the assurance framework in the 4 views that we represent here today. So I think Roland introduced this slide and explained the development and operational concept in a global view. And Yan just presented the argumentation view in our framework. And I will present what we called the scenario-based version of it. This looks a little bit complicated, but maybe you see that is the old classical V model in another way. You can still see the V on the left side, the classical step specification architecture component module, and the V on the right side is broken down in 3 parts. So these are the classical parts of the V: verification and validation, and we add something that we called evaluation of residual risk, which is important in the case of automatic driving systems because it tries to evaluate their residual risk in the ODD. So the V&V method is based on the Pegasus approach. How can we find Pegasus in this picture? You see in Pegasus we had a model for the ODD. We used logical scenarios to represent the ODD in Pegasus for a highway application, the highway pilot. And we use this logical scenario to evaluate the residual risk of the highway pilot. So Pegasus uses a very concrete or fixed view in this V&V process. We had a clear concept of the use of the test instances, so simulation first for identifying problems in the ODD with our function. The simulation should be supported by proving ground tests, and the idea of the field operational tests or the validation phase was to find surprises and to integrate the stochastical aspects of testing. So now coming to the basic idea of the VVM approach. So the idea of the VVM approach you see on the left right side. On the right side, so the idea is an early alignment of the whole process to the needs of argumentation. It's the first step. And then to control and manage the risk in specifying the behavior of our system, as well as control it in the validation and verification part of it. And the third idea is to use the same model or the same representation of our operational design domain on the left and on the right side in specification as well as in verification and validation. So, how do we realize it? So the first thing is, how do we get a model of our operation design domain? So the idea is now taking up the idea of Pegasus with logical scenarios. The logical scenarios use the 6-layer model. Layer 4 models the behavior of the dynamic objects in a concrete scenario. In Pegasus, we looked at highway scenarios. Here in VVM methods, we look at urban scenarios. So we redefine the way of modeling the dynamic constellation of the dynamic objects. So, and by restarting this model, we model it in a way that the basic concepts here were disjunct. So the idea is to have disjunct scenarios. This is better compared to the Pegasus approach because we can define the behavior for this scenario and for concrete disjunct scenario, and it's not defined a little bit in scenario A and a little bit in scenario B. As well as we define these scenarios for evaluating the residual risk, we don't have the problem to calculate the risk concerning of the overlap of the scenarios. So this is what you see here in the picture is exactly the idea of these disjunct scenarios. So we have a coverage of the ODD by these overlapping free scenarios to make sure that there is a difference between the approaches. We add the attribute core to the logical scenarios to make clear that there are some special requirements we used instead of a normal logical scenario. How can we get such a model? So we get the initial solution by the 3 steps displayed here. We start with the initial ODD, mirror it with our customer function, identify the scenario relevant factors, and get functional descriptions of our scenarios. In these functional descriptions, we declare parameters and attribute and apply these disjunct core ID to get logical core scenarios. So the logical scenarios have declared parameter lists to handle it better. With knowledge and measurements of real data, we enforce an scenario database, or let's say a scenario parameter database, to measure in real measurements the distribution of concrete parameters in this context to have them in our process, to align it in the design or to use it in simulation to identify critical areas or, let's say, normal driving areas. So what do we have to the design? So the first thing is the ODD meta model. The next idea is to add a problem, we call it problem space analysis, which gives us a deep understanding about the problem space. So problem space here means the operational design domain and the customer function and the relation between them. And this is the basis for an hazard and risk analysis we use to define safety goals and the behavior of our function. The third idea is to integrate a risk management system, we call it in VV method risk management core, to control the level of risk designed in the behavior process. So to go a little bit more in the details, you see here the V model. The first step we add is problem space analysis. This is a systematic analysis of the problem space, providing us a deep understanding of the domain and the problems of the automatic driving function that we want to design. The next step is that we have to integrate the normative aspects of behavior. Normative aspects here mean the legal requirements, the ethical and the society requirements on the behavior of our automatic driving system to incorporate it in requirements. So this is how the laws came into requirements of our system. So the third step is hazard and triggering event or condition analysis. So we have our ODD model, we have our scenarios, and we try to identify systematically the hazards that can appear in these scenarios and triggering condition that could trigger events that can become hazardous. So to manage these kind of risks that we identified, we use the risk management core. The risk management core is a concept to identify safety measure in relation to an accepted residual risk. So if we have a hazard, we identify a measure and we control the measure in such a sense that the risk resulting from these measures is in an acceptable level. So what do we have to do on the verification and validation part? Here we try to integrate the evaluation of the residual risk so the main pressure is on the validation and verification concept, who arranges the results that we have, the evidences and the we have to get for the argumentation. In verification, we must prove that the automatic driving system is implemented as specified. So the task is testing requirements. One key word that appears is scenario-based testing. What does it mean? First, we need a parameterizable model for the scenarios. You see it on the left side. And then we need something which generates concrete scenarios which could be tested in simulation or on other test platforms. So there are many possibilities for defining such generators, ranging from a list of complex algorithms to optimization algorithms. So you see examples here: requirement-based testing, adaptive sample testing, Monte Carlo simulations, so stochastic testing methods, or search-based testing, which include these optimization algorithm. The representatives, so the first two methods usually were used in the verification part because they only generate a few concrete scenarios, and if you go to the right side, the generated concrete scenario increases, so that these methods are usually assigned to simulation methods. So Monte Carlo testing and search-based testing are tools that we use in the residual risk evaluation part of the V&V process. So fields of application of these scenario-based testing methods, you see on the left side typical test objects, and on the right side typical platforms. So the effect chain we analyze here is the Sense Plan Act effect chain. You see that the scenario-based technique can be used on each of the platforms: simulation in the loop, hardware in the loop, and proving ground. A little bit different is it with the field operational tests. Here we don't have concrete scenarios. Here we have frameworks that give a broader description of a scenario where we have to perform our driving experiments to be sure to cover with the validation part the whole ODD. In some sense, I explained this slide before. So the workhorse for the mass processing of data is the software in the loop testing. The proving ground test platform is the specialist to confirm the results we get in simulation, and the hardware in the loop test platforms develop to another platform that could support proving ground aspects for some components. So what's important here is to generate a seamless exchange of test cases between simulation and proving ground on one side, or simulation and hardware in the loop test platforms on the other side. The other point is to have a strategy to identify representatives in your immense amount of simulation results for proving them on proving ground or on hardware in the loop test benches. So field operational tests. The test object here is, are we specified correctly or sufficiently, or do we get stakeholder approval? So here, we do not test requirements. We operate our vehicle or our automatic driving system equipped in a vehicle in the in the real world context and see if it fits or if it doesn't fit. So search-based testing is a tool which we use in the residual risk evaluation. The parameter space of core scenario instances is searched using an intelligent search-based algorithm to determine the probability that collisions of severity 0 or 3, so this means near misses, or collision with death will occur. This simulation-based testing is used to prove functional correctness and compliance with risk acceptance criteria while the system is operating with the implemented behavior. This method verifies the ability of decompose data fusion, planning, and acting algorithm to handle the range of the known concrete traffic scenarios with an acceptable risk. Chosen edge cases resulting from the designed process are controlled on proving ground. The process must be designed to achieve a high level of coverage of all risky areas. For this reason, usually a multi-stage process is used that uses optimization approaches and statistical cluster analysis to determine relevant areas. So this is my most complex image, and lunch is waiting outside. I'll keep it short. You see 3 blocks. The left block, here we find the discussed sub-steps of the design process, where we apply our ODD meta model and the scenarios saved as the shape of the design space. On the right side, a kind of structured wastebasket that we haven't talked about yet. You can use the content by using the scenario model as a data filter for classification and thus recycle the scenario knowledge which is in these kind of measurement you get while validating the system. These informations are very valuable inputs for the development and validation process. It reflects real world driving. On the bottom you can see a rough methodological structure of the validation and verification process. And you see here the use of scenarios. In verification for scenario-based testing, the scenario model or the algorithm are used to generate concrete scenarios for testing out of our scenario models. On the left side, in validation, it's a little bit different. We don't want concrete scenarios. We want a generation of a scenario framework to put our systems in these frameworks to be sure that we tested in each scenario which belongs to our ODD. And the next task is to see if we find something that we haven't thought about, a new scenario, a new parameter that we didn't realize, to be sure that our ODD meta model covers as good as it can the concrete ODD, and that we can say we developed and we validated and verified at a valid coverage of the real world. So let's come back to Pegasus. What are the differences? Uli Eberle showed you this slide in his presentation. If you look at these slides, I think it is clear the difference was a very small view of Pegasus on the problem and a bright view and bright integration of the V&V method approach to the complete design and verification and validation process. So you find the components, 6-layer model, and scenario-based approaches on the right side, and a more complex framework to argue that we developed an automatic driving system that has an acceptable risk. So the necessary evidence to argue that our automatic driving system is free of unreasonable risk can be provided with a few additions to the classical process. The consistent use of a valid ODD model is one of these parts, and incorporating risk control and management in the design and in the verification and validation part is another component. The scenario-based validation and verification, complemented by the assessed residual risk, is the third part, and Roland pointed on it. So identifying gaps between intended and specified and implemented behavior are closed by incorporating monitoring reviews in the process. So the evidences and artifacts obtained through the extended process are taken up by the argumentation layer. Jan told it before, so that we can reasoning the absence of unacceptable risk by our automated driving system for passengers and other road users. Thank you for your attention.